go, I will come back to the slide again because I want to discuss it first and then I want to go to the second one. Okay, now see this cluster one. In a cluster one, there are 4 points, and just concentrate on those 4 points will have 3A and 1B. If you see the mode-based approach, I will say A. For the cluster 2, I will say B. But we know that cluster 1 also has some points related with B, and cluster 2s have some point related with A. So if we use only B or A, there will be loss of information. So we said, okay, we will not define it by using mode. We will use a proportional distribution of all the categorical values. So in this way, there will be no loss of information. Like for the cluster 1, it will be, there are 4 points, so it will 1 by 4, 3A, and 1B. So no loss of information, and we will use this center. Now, second one. New distance measure instead of binary distance measure based on data set. So what is the problem here? I will go back to this. No, I will come back to that slide, so I will not miss any slide. But I want to show you the problem. Why this is not a correct way, 0 and 1. Now, there are 3 attributes value: child, old, and young. Hamming distance says that if values are not same, the distance should be 1. So distance between child old is 1, child young is 1, and young old is 1. But is it necessary the distance between child old it should be equal to the distance between young and old? Probably not. So we should try to find out the method by which we can compute the distance using the data. The third is we should try to find out the weight for the numeric data, and then we should try to make sure the contribution of the categorical and numeric data should be the same, and there should be no need of gamma. So this is, I think, I'm running time. I have to show more slides. So this is the proportional distribution, which I discussed it here. The center should be defined for the categorical attribute using the proportional distribution. So basically, you have many attributes values, so you have to have numbers for each attribute value. Some of the attributes are numeric, some of the categorical. So for numeric, center should be defined using mean, and for categorical, proportional distribution. And I have already discussed this problem that if you're using the mode, you will lose the information. So we should use the proportional distribution. I've discussed this thing. Now, what is the approach I have used to compute the distance? There is a well-defined theory which says that distance between 2 attribute values can be computed using other attributes. Finding the relationship between attribute values with the other attribute values. We can. So this is called, we can compute the distance using frequently co-occurring items. Means one attribute values, if it is occurring with other, we see the relationship with other attributes, it can define. the relationship. So I use, because I'm running out of time, I use the same concept to find out the distance. Now, this is the important thing, so I should discuss with you. The distance between the theory is we first developed the theory for the classification, and then we extended it for the clustering. So here you have some classes. The distance between two attribute values for, let's say, attribute A and B, we can find out using its correlation with the classes. So we will find out the correlation for any subset of classes. So there are 4 classes, you can find out any subset. And the relationship or other attribute values, let's say B, for B, not of that subset. Means here, if you want to find out relationship between R and S, the distance, find out the correlation between R with any subset W and the relationship between S with not of W. However, there is a problem because you may have a lot of subsets. You have to find out a particular subset for which this distance is the maximum. And this will be the distance between R and S. You have a large number of subsets. So basically you will be having 2 to the power k subsets. So it becomes computationally expensive. We propose a numeric, a linear approach to find out the subset for which the distance will be the maximum. In clustering algorithms, we do not have a class. So what we do for the clustering, if we have m features, I will compute the distance between 2 attribute values for all other attributes and will take the average. So this will give me the attribute values for any 2 categorical attributes. So now I have the distance between 2 attribute values from the data. So the first problem is solved. Second problem is solved, that I can compute the distance between 2 attribute values. What is the third problem? And these are the values, because the value between 2 attributes value can be between 0 and 1. And distance between R and S and R will be the same. And distance between the same attribute value. But it's not always 0 and 1. It is between 0 and 1. So if I have to compute the distance between categorical attributes and the center, this will be my approach. So I want to compute distance between X and A and B. So I will compute XA and XB. Now, the third point was how to find out the significance of attribute for numeric attributes. All attributes are not the same. So for this, what we did, we discretize all the numeric attributes. So now it's a categorical attributes. Each categorical attributes will have many attribute values. We compute the distance for each pair. So for example, in this case, there are values A, B, C, D, different pairs A, B, B, C, C, A, C, D. So for